Okay, now I want to take some time to explain the difference between quantitative data and qualitative data. So you can freeze this and copy these notes, and then we can keep going. So quantitative data are measures of values or counts and are expressed as numbers. So basically, whenever you hear quantitative, think about numerical. Some examples are your height and your shoe size, right? Those can be counted. Qualitative data, on the other hand, are measures of types and may be represented by a name or a symbol. So when you read qualitative or when you hear qualitative, think about a category. So some examples would be color of your eyes, favorite music genre, or favorite food. Those are categories. So let's check out an example which is going to basically make this one stand out. So here, example 2, a class at Hoover High School, students were surveyed on the type of movies they preferred. And here I think we need a comma. The researchers came up with two graphical displays. The first one is below. Now we have to find the mean, the median, and the mode. Now notice here that the genres are in a category A, H, R, and C. And on our previous example, that was labeled in numerical data. Here the smartphones were labeled as 1, 2, 3, 4, and 5. So there's a big difference already. So let's begin by calculating the mean here. So here we have a mean. And remember, for the mean, we would get our values and then multiply them by the number of frequency, and then we would add them together. So here we would have 8 times 4, which would be 4a. And then we would add that to h times 5, which would be 5h. And then plus 9r plus 15c. Now here you don't have to be a math wizard to realize that we're in a really, really big problem here. Because how in the world are we going to add in 4a's plus 5h's? And on top of that, we have to add 9 R's and 15 C's. There's no practical way for us to do this. It's really, well, we're stuck here. We can't add the A's and the H's, and the R's and the C's are not common terms. So it turns out that here we're not going to be able to calculate the mean. Well, let's see if we can find the median at least. So median. Now in our previous problem I taught you a trick, right, that we could add all of the values together, and then we could divide it and see if we had an even number or an odd number, etc., etc. However, the reason I was able to do that is because our data was already categorized in numerical order. So here we have a 1, a 2, a 3, a 4, and 5. Our data is secretly categorized from smallest to largest. Let's take a look at the one we have now. Here we have A through C, but how do we know that A is smaller than H? And how do we know that H is smaller than A? Or how do we know that C is bigger than A? Right? We don't know that. And here, to point this out a little bit more, let's write this as a list. Writing this as a list, we see that on our list we have A with a frequency of 4. So here we would have 1, 2, 3, 4 A's. Then we would have H with a frequency of 5. So we would have to draw, or we have to include 5 H's on our set. So 3, 4, 5, etc., all the way up to C with a frequency of 15. But again, I don't know about you, but I'm not sure how to rearrange these values so that we have smallest to largest. So here we can't even calculate the median either. We cannot calculate anything from this kind of data set because it's not numerical data. However, what we can find is the most commonly occurred item, and that's obviously called the mode. So for the mode, we're not calculating anything, but we can see that the item with the most frequency was C, because it had a frequency of 15. So here the mode is going to be 15. And this is typically how many people like to use bar graphs. They like to use bar graphs with qualitative data as opposed to quantitative data. When we have quantitative data, we tend to use something called a histogram. But here we see that the mode is 15. And remember that the researchers came up with 2 graphical displays. So let's take a look at the second display. And here we have it. So after a couple of seconds, you should be able to realize that this is just a rearranged version of this. And we can do that because remember, there's no clear distinction of which item is bigger or which one is smaller, right? We don't know that A is larger than H. We don't know that R is larger than A. And quite frankly, for bar graphs, we really don't care about that, right? So here, for qualitative data, the bars can be rearranged because we don't care about median or mean. All we care about is kind of like mode here. So the mode is still 15 regardless of how it's rearranged. And again, just bar graphs are really good. They're a really good way to show relative sizes. We can see which type of item is most liked and which type of item is least liked just at a glance. So here we can see that genre A was the one that was the worst and genre C was the best. So try the last set of examples, and I'll see you tomorrow, and we'll cover something called a histogram tomorrow. So good luck. If you have any questions, please email me, message me, and please consider going to or attending Zoom office hours.